Hey guys, and welcome back to another Studying Works video. In this video, we're going to be going over the ideal gas law, the combined gas law, and how you can derive gas relationships without using memorization. This video is very important for AP Chemistry, so let's get into this video. So the first thing you'll need to know in order to understand gas law problems is what is the ideal gas law and what is the combined gas law. So right here I have the formula of the ideal gas law, which is PV equals nRT. But what does that mean? It means that the pressure in atmospheres times the volume in liters equals moles times the gas constant, which is in these weird units, which we're going to explain in a bit, and then that also times the temperature in Kelvin. And I will also explain why all of this is very important later as well. Now, the combined gas law is when we have our initial pressure, times our initial volume, divided by our initial moles, times our initial temperature, equals our final pressure, times our final volume, divided by our final moles, times our final temperature. And now to kind of talk about the applications. So with ideal gas law, it's more in one moment of time. We're specifically focusing on one gas and its interactions. Meanwhile, with combined gas law, we're kind of thinking about a before and after. So it had these properties before, and now what will it have after? So that's kind of when you would use combined gas law. And these may look complicated, but it's very easy to cut down once you get into some problems. Let's take a look at our first problem. A fixed container with a volume of 3.3 liters contains a gas at a temperature of 25 degrees Celsius, creating a pressure of 800 torrs. How many moles of gas are in the container? So, at first it may sound complicated, but the first thing we have to do is figure out, well, what gas law are we using? And you will learn that that is relatively simple, because the way we can figure out what gas law we're using is by using the comparisons that I talked about before. Combined gas law will usually mean we're comparing some sort of before and after thing, but I don't see any sort of before and after aspect to this problem. I see a volume, I see a temperature, I see a pressure, and I'm being asked for moles. So it doesn't look like I'm having any sort of comparison here. So that means we're going with the ideal gas law. PV equals nRT. So now, the first thing we need to do, a good habit, which you don't have to do, but it's always a good idea, is to label everything you have. So first, you have your pressure, which is 800 torrs. And remember, we have to convert that to atmospheres for the ideal gas law. And here's why. Because if we were to write the ideal gas law in units, we would have atmospheres times liters equals moles times liters times atmospheres divided by moles times Kelvin times Kelvin. And this is just me rewriting the ideal gas law in units only, because pressure is in atmospheres, volume is in liters, and N is in moles, R is in these weird units here, and T, our temperature, is in Kelvin. So now, why is this important? Because if we look at it, our moles cancel out and our Kelvin cancels out, so we're left with L times ATM equals L times ATM. So our units are equal, and that's what's really important, because if we did not convert our pressure to atmospheres, watch what would happen. We would have torrs times liters equals moles times the weird conversion factor, times Kelvin. And you'd see in this case, we get L times torr equals, and remember these cancel out, L times ATM. So these are not equivalent units, meaning that we wouldn't be able to get our answer right. It's like saying 5 equals 7. That can't be right. That's why we have to convert our units. So now, going back to the problem, so now that we know why we have to convert our pressure, let's convert it. So this conversion factor will be given to you on an AP test. So we have 1 atmosphere for every 760 torrs. And that is 1.05 ATM about. And now our volume is already in its desired unit, which is liters, 3.3 liters, so we do not need to convert it. Our moles is what we're trying to find. Our R value is already always given to us. And our temperature is 25 degrees Celsius, but remember, we want it in Kelvin. So to get it in Kelvin, we just add 273 and we get it to be 298 Kelvin. And now that we have all the proper units, we can solve the problem. So our pressure times our volume equals our moles, which is what we're trying to find, times our R value, our gas constant, times temperature, which is 298. And now this just becomes an algebra equation. Solve for n. N equals 1.05 times 3.3 divided by 0.08206 times 298. And so our moles equals 0.142 moles. And now let's go on to our next problem. So let's take a look at our second problem. A container has a volume of 5.0 liters and a pressure of 760 torrs. What will be the pressure in atmospheres in the container when the volume is 2.0 liters? So this one, we can see that we are given an initial volume and an initial pressure. We're asked to find the final pressure, and we are given the final volume. So this one is a comparison, so we can use the combined gas law. Now you may ask, why is the page split in half? And that's because there are two different ways you can solve this, and I'm going to show you both of them. The first way is to solve this and find the pressure in torrs, and then get the pressure in atmospheres by using the conversion factor. And the reason why we do not need to convert it before putting it into the combined gas law is because there's no R value. In the previous one, we had an R value where we needed to cancel our units. But in this, there's no R value, so whatever units we use, it doesn't matter, as long as the units are the same on both sides. So we can see that our volume units are the same on both sides. So when we solve using torrs, our end answer will also be in torrs, and we'll need to convert to atmospheres since the problem asks for atmospheres. So looking at this, we know our combined gas law. And so looking at our combined gas law, earlier you noticed that I said anything that is not mentioned in the problem can be assumed to be constant. So we can see moles is not mentioned, so we can cross moles out. And temperature is not mentioned, so we can cross those out. So now we're left with the equation, and now we can solve for our final pressure very easily. We have our initial pressure, which is 760 torrs. We have our initial volume, which is 5.0 liters. And it is equal to our final pressure times our final volume, which is 2.0 liters. Now this one, I'm not going to write the intermediate step. You should know how to solve this from algebra. Our final pressure equals 1,900 torrs. And now remember, we have to convert that to atmospheres. So in 1 atmosphere, there are 760 torrs. Sorry, there's not much room. And we will get 2.5 atmospheres. And that is our final answer. But now I'm going to show you the second way you could do this. So we know we want our answer in atmospheres, so we can convert our initial pressure to atmospheres and solve. So we have 760 torrs, and we know there is 1 atmosphere for every 760 torrs. So we have 1 atmosphere. And now I've already derived the equation from here, so we can just apply it here. And now we have our 1 atmosphere times our volume, which is 5 liters, equals our final pressure times 2.0 liters. And now again, using algebra, you can solve and you'll get that your final pressure equals 2.5 atm. And that is the exact same as our last one, and we solved it a different way, so it shows that both of these methods work. So now let's get into the final part of the video. Another important thing to understand is that chemistry is mostly about understanding rather than memorizing formulas or doing a ton of math. So here I'm going to show you how you can really grasp the understanding of all these different gas relationships. So this works in an ideal gas, so whenever we have an ideal gas in chemistry, you can derive gas relationships this way. So we have PV equals nRT, that's our ideal gas law. And now, how can we find out what one of them is in relation to the other? So we can solve a literal equation. So let's say we wanted to find pressure. We divide by volume on both sides, and we get pressure equals moles times the R value times T, all divided by V. And now, there's something really cool about this that we can do. So, since all of these are being multiplied and divided together, this is actually also a proportional relationship, meaning that if one of them changes and we hold the rest constant, we can use these proportional relationships to find out what the factor of change is. So R is always a constant, so R will not count in our proportional relationship. So we can say P, our pressure, is proportional to moles times temperature divided by V. And what does this mean? It might be so confusing. Let's take a look at this. So let's say we have a problem where our moles is 1. So we have moles is 1. Our temperature is 1. And we know our R value. I'm not going to write it all out, but just imagine that our R value is there. And our volume is 1. And just imagine there are units there as well. So then that means our pressure is equal to R, right? But what if we were to double the volume? So if we had 1 times R divided by 2, then our value would be R divided by 2. And now how can we find this without plugging in our numbers like this? What we can do is we can set them proportional like I have here. So we can see P, pressure, is proportional to 1 over volume. Because everything else is constant, it doesn't matter. So if we were trying to find out its relationship with moles, we would set temperature and volume constant. And if we were finding temperature, we would set moles and volume constant. Now we know that we doubled V, so as V doubles, our pressure becomes 1 over the volume, which is 2, times pressure. So our pressure halved. And we can see that this is actually true when we do it here. And you can do this for any one of them. If you wanted to solve for moles, you could divide both sides by RT, and then you could derive the proportional relationship like that. And that is how you can easily find out the relationship between all of these different properties of gases. And it is so important in chemistry that you understand them. Thank you for watching. I hope you learned something from this video, and I will see you in the next video.